Okay, we're on. Good. Break. It's Rue Friday. I always wear my Rue sweatshirt on Friday. I'm gonna have to get a T-shirt now because hopefully it'll turn into spring here pretty soon. I'm gonna do these two problems on your homework. At least get them set up for you, and you can do the algebra. You can finish the algebra thing. But let's just take a look at what's going on problems 8 and 9. I'm going to get a phone call here in about 6 minutes. So I'm hoping that I will not pause. I'll just break it up into two pieces. But here's the initial problem. This is chapter 8. This is problem 10 on chapter on the momentum stuff that I gave you. And I could have sworn we were going to get center of mass things. I'm going to have to teach you center of mass when we come back because I think it's an important part of conservation of momentum, because the center of mass of a system is also conserved. And that would be one way we could solve this, maybe, is if we looked at the center of mass of a system and calculated, but we don't know how far apart these guys are. The velocities of the center of mass is conserved, and you have no idea what I'm talking about. But we'll talk about that later. Okay, we'll talk about that after break. But two billiard balls. Okay, here they are. They're coming at each other, and I'm not gonna. I'll go. I'm not going to bother typing in these things, but. So here we go. We got two billiard balls, and with the same mass moving towards one another. Ball 1 travels in the positive x direction with a speed of v1 initial, and I like to use v1 naught. And ball 2 travels in a negative direction with a speed of v2 naught. And the two balls collide elastically. Okay. There was no jiggling. There was no noise. Well. We're gonna say that any loss of energy was negligible, so therefore they collided elastically. So what do we know about that? That the kinetic energy is conserved. And the nice thing about kinetic energy is we don't have to worry about the directions of things. I saw someone put on there the little what did you learn today, Dorothy thing, and they said that that they learned that in an inelastic collision, the kinetic energy is not conserved, and in an elastic collision, the kinetic energy is conserved. So write an expression for the horizontal component of the system's initial momentum in terms of m, v1 initial, and v2 initial. Well, that's not hard, so we can do that part. Okay, so I'll do the easy stuff for you. How's that sound? All right. So this is problem 10 on the momentum. So this is problem 10 on the momentum. Now let me expand this and get this a little bit bigger so we can see what the heck's going on. All right, so they wanted us to write an expression. So here's basically what's going on. We've got two billiard balls moving at each other. They got the same mass. So the momentum before in the x direction is going to equal the momentum after in the x direction. And also, down here, we're going to say the kinetic energy before is going to equal the kinetic energy after. All right? So we've got m v1 initial plus m v2 initial is equal to m v1 and final plus m v2 final. Now, that's the initial thing, but let's actually put in the numbers. So we've got m, and it was going in the positive direction at what? Is that correct? Am I correct in assuming this? 2 meters per second, and v2 is going 1 meter per second in the opposite direction. So let's put that in. So here we go. So we come over here and we go, all right, well, that's m. v1 is Jiminy Christmas. My brain is cooked. 2 and 1, dumbass. All right, so sorry about that. So V1 initial is equal to 2 meters per second. And here's where you got to be careful. V2 initial is equal to negative 1.0 meters per second. Remember, momentum is vectors. So we got 2 plus negative 1 here, is equal to m times v1 final plus v2 final. Okay? And it says that they bounce and they both go in opposite directions. Okay? They bounce and they go in opposite directions. So, what do I have here? Well, look what I can do. I can cancel the m's. And so I wind up with 1.0, basically meters per second, is equal to V1 final plus V2 final. But wait a minute. I want to change that. I want to change that 1.0 meters per second is equal to V1 final plus V2 final. But I know this. I know this. I know that V1 final is negative. But I'm going to get two answers. So I'm going to go ahead and go and pretend that I didn't analyze it that far. And they want us to find what is V2 final. Okay, we can do that. So we'll do this. We'll say, hey, the kinetic energies are equal. And so I know that V2 final is equal to 1 minus V1 final. Okay? I know that. And I also know that their kinetic energies are equal. So I'm going to say 1/2 of m v1 naught squared plus 1/2 m v2 naught squared is equal. And there's my phone call. So I'll be with you in a minute.